Question 26 says that if two vectors A is equal to I cap plus AJ cap plus BK cap and B vector is equal to 5I cap plus 15J cap plus 25K cap are parallel to each other, then the values of A and B respectively are. Dear students, it is given that two vectors are parallel. In such a case, the ratio of the individual components of unit vector is same. That means the ratio of the I components, that is 1 by 5, should be equal to A by 15, and that should be equal to B by 25. From this section we can write down that A will be equal to 15 by 5, that is 3, and combining these two expressions we can write down that B will be equal to 25 by 5, that is 5, and therefore the values of A and B are 3 and 5, meaning that for this question the correct answer that matches with our data is option number 4. Now let us proceed to the question 27. Dear students, question 27 says that the position of particle on a straight line as a function of time is root x is equal to 2t plus 1. Then we have to find out the dependency of velocity on time. Now dear students, here in root x is given as 2t plus 1. We can further write down that x will be equal to 2t plus 1 square, or velocity, which is nothing but dx by dt, can be written as 4 into 2t plus 1, that will be equal to 8t plus 4. Now dear students, clearly the velocity is neither inversely proportional to t, which means option 1 is incorrect. It is also not inversely proportional to root t, therefore option 2 is incorrect. Dear students, the velocity is also not proportional to t square, therefore option 3 is incorrect as well. Let us now find out the acceleration, which will be dv by dt, and this turns out to be equal to 8, meaning which is a constant. And hence for this question the correct answer is option number 4. Now let us move to the question number 28. In question 28, a particle moves with an initial velocity v0 along a straight line with a retardation alpha v. Alpha is a positive constant and v is velocity at time t. Then we have to find out which among the following option is correct. Now dear students, here retardation is alpha v, so we can write down that v dv by dx will be equal to minus alpha v. We are using the minus sign because it is retardation. Further we can write down that dv will be equal to minus alpha dx. Dear students, we can integrate these left hand and right hand sides and find out the stopping distance. So 0 to x and v0 to 0, that is the final speed is 0. On solving this we get x to be equal to v0 by alpha, which means that the distance covered by the particle before it comes to rest is v0 by alpha. If we see all the options, clearly see that the option number 3 matches with this data, and therefore option number 3 of this question is the correct answer that we have to mark. Dear students, we can solve it further as well, because we know that dv by dt is equal to minus alpha v. On solving this differential equation we get that v is equal to v0 e to the power minus alpha t. Clearly the velocity decreases exponentially with time, and therefore option number 4 is incorrect. Similarly we can check other options as well. However, for this question the correct answer remains to be option number 3. Now let us proceed to the question number 29. In this question the dimensional formula of physical quantity is given as MPLQTR, then the physical quantity is. So dear students, 3 physical quantities are given. Let us write down their dimensions. The first one is angular momentum. The dimension of the angular momentum is mL2 t minus 1. The dimension of the Planck's constant is mL2 t minus 1, and for the Young's modulus the dimension is ml minus 1 t minus 2. In first case p is equal to 1, q is equal to 2, r is equal to minus 1. In the second case p is equal to 1, q is equal to 2, r is equal to minus 1, and in third case p is equal to 1, q is equal to minus 1, and r is equal to minus 2. Clearly dear students, we can see that the option number 1 and 2 both of this question are correct, and hence the final answer should be option number 4. Now let us move to the question number 30. Question 30 says that a train is moving on a straight track and it has a uniform acceleration. The engine of the train is passing a pole with speed u and the next pole with speed v. The speed of the train when the engine covers 2/5 of the distance between the consecutive poles is. Dear students, we can use the equation of motion that v square is equal to u square plus 2as. Now, when the train moves from the first pole till a distance of 2/5 of the distance between the poles, we can use the equation and write down that the velocity at that point, that is v1 square, will be the initial velocity square plus 2 into acceleration into 2d by 5, where d is the distance between the poles. And when it moves further to the next pole, we can write down that v square should be equal to v1 square plus 2a into 3d by 5. Now dear students, solving these two equations, we can eliminate a and d and find out the value of v1, which will be equal to under root of 3u square plus 2v square by 5. Meaning that for this question the correct answer is option number 3. Now let us solve the question number 31.